Last but not least, we have example 7, where we're asked to graph the following three things. For A, we're looking for e raised to the x plus 3. So again, we can put a box around our basic graph. We've already learned how to graph e raised to the x before. I almost did it again. Remember, you can't just take part of an exponent. You have to do the entire exponent, okay? So the difference is plus 3, and it's happening on the inside. Remember, the inside is the opposite of what you think it's going to do. So it looks like we're going to the right, but we're really going left 3. So if we were to graph this, we'd have at 0, 1. Remember, this is the regular e to the x, but now we need to move to the left 3. 1, 2, 3. And now we just draw that exact same thing again, okay? Cool. So for B, we have two differences. We have this negative and we have this half. So let's talk about the negative. The negative is affecting the x. If it was affecting the y, it'd be on the outside. So since it's affecting the x, we flip over the y-axis. This half is connected by multiplication. It's connected to the x. X means we're going to have some type of horizontal shrink or stretch. And because it's on the inside, it's going to be the opposite of what you think it's going to do. So we are going to have a horizontal stretch. Okay, so you want to think opposite here. Alrighty, so I want to show you guys on my computer what this actually looks like, because I think that would be easier. So essentially, this right here is the graph of e to the negative x, okay? Now, if I were to graph this is the graph of e to the x. Now, if we do e to the negative x, it's going to flip over the y-axis, okay? So there's e to the negative x in the purple, right? So now if we take that e to the negative x and we multiply that x by 0.5, you'll see the horizontal stretch with the red one. So the red one is the horizontal stretch. So we basically just took the ends of the purple and stretched it horizontally, okay, to the red one. All right. And then for the last one, we need to talk about what our basic graph is, which is just our exponent. Remember, you have to take everything here, and we talk about our differences. We have this 2, which is connected to the x, so we know it's going to be horizontal, and that looks like it's going to be a stretch, but it's really a shrink because it's on the inside, so we think opposite. And then we have this negative, which is affecting the x right here, so we flip y. And then we have this negative on the outside, which is affecting the entire box, which is our function y. So here we flip x. And then this 1 is on the outside, and it's a positive 1. Don't be thrown off by this negative. The number 1 is actually positive. So we're going to go up 1, okay? And remember, this plus 1 should be the very, very last thing that you do. Always start from the inside out, okay? So I'm going to go ahead and do that on my computer again, just to show you guys in a neater way. So if I were to do e raised to the x, we know that that looks like this, right? So now I'm going to take e to the x, e raised to the x, and I'm going to multiply that x by 2. So that 2 is going to be a horizontal shrink. So look what happens to the red. Okay, so it shrank. So we just took the black, and squished it in horizontally, and we shrank it, okay? So now, on the screen, we just have e raised to the 2x, okay? So now after e to the 2x, I'm going to add the negative. So I'm going to do e to the negative 2x, and let's see what that looks like. Remember, the negative is affecting the x, which means we're going to flip over the y. So watch it flip over the y. Boom. Okay? So now this is what we have. Okay? So now we have that negative on the outside of our box, which is affecting our y, so we're going to flip over the x-axis. So watch it flip downward. Boom. Okay? And now that we've flipped downward, we're going to tack on that 1 in the very, very front, and it's just going to shift it up 1. Boom. Okay? And that would be our final answer. This is our final graph.